Hey, good afternoon, people that watch my videos. Today we're going to do another, we're going to go over Neutron Decay Cosmology one more time. And this is like super elevator pitch, hopefully, rather than 20 minutes. I've already delayed. Principle is very simple. Even in Big Bang model, there's originally a bunch of hydrogen. This hydrogen is gathered through gravity and other binding effects that you guys seem to neglect most of the time. But magnetic couplings, etc., electrostatic, binds together, gets heavier, maybe becomes a star, fuses, becomes helium, all those other elements, gets heavier and heavier, like a rotating ball, a point on the surface, until it gets here. Okay? Nebula, protostar, star, neutron star, boop. Here we are at the edge of an event horizon. Okay, so we started off basically with potential energy. Okay, when it was hydrogen and it was 1 proton per cubic meter. Okay, that was the density, that was the energy density in those conditions. 1 proton per cubic meter. Okay, this is in the deep voids of space. And they say 1 proton per cubic meter almost every place but you read, but that doesn't make any sense because there's got to be an electron for every single proton. So it should be 1 neutron per unit, and we really should be using neutrons as like some kind of scale. Anyways, so this hydrogen goes through evolution, works its way until eventually it is at the edge of an event horizon. It's a neutron star about to collapse. Okay, now we're at the event horizon. Gravity is practically infinite, whereas here there was no gravity at all. You're in free fall the whole way, possibly. But at that moment, your gravitational acceleration is probably near C. You have been turned into a neutron. This is kind of important. Okay? Neutron stars. They crush the proton and electron back together until you have just neutrons. Okay, there's not even room for the electrons. The electrons are like the skin on top of the charge now. They've been so pushed together. Okay, we're gone from 1 proton per cubic meter to 10 to the 47th grams per cubic meter, maybe more. That's not the point. The point is what happens here at this inversion. Okay? And neutron decay cosmology says that simply the neutrons become the vacuum energy for 1 Planck moment, just a rotation, and then they re-emerge because distance is a relative thing. They re-emerge because there is 1 moment of time that every single point in space shares this. See my ADS space, anti-de Sitter space collapsed, caused the universe video regarding that. But my postulate is there's infinitesimal time, neutron falls in, reappears in deep space, becomes primordial atomic hydrogen, which seems like a just logical thing, which is exactly what it's going to do. It's going to decay. The neutron is going to decay. It's going to decay into a proton, electron, and an anti-neutrino, which we'll use sometime later, which is amorphous atomic hydrogen. Amorphous atomic hydrogen, hydrogen itself, atomic hydrogen, is difficult to detect if you ask around. When this newly forms from the decay of neutrons, this is not even going to have a stable electron. It can't emit photons, it can't absorb photons. It's like amorphous protons and electron soup. Okay, it's dark, it's undetectable, it doesn't interact with things, but it's still there, it still contributes energy and mass. It just has no qualities. One suggestion is that we start taking pictures and have a polarizing filter and do one rotation of the polarizing filter if you can get multiple views of someplace. You know, you guys probably do that, but the more we do that, because that kind of polarization will give us extra insight in terms of three-dimensionality. Hydrogen, amorphous hydrogen, can't detect it. Suddenly, eventually, it gets a stable electron. Now first scintillation. Okay, it can emit and absorb photons. This is first light in the Big Bang model. It's just this myopic view. Then the hydrogen gathers, usual evolution, constant cycle through. The CMB is the skewed view of this moment actually. Neutron decay is the quark soup that you guys have in the black Big Bang model. It's like the quark soup, the dark period, and then first light. Boom. This is all in here. It's just, I believe that space lenses the view much more than you seem to contribute. Okay, it accounts for the CMB, it accounts for the Hubble Doppler. The gravity itself of the universe curves space. We are trapped inside the observable universe. It's sort of a singularity, and it's not really a singularity at the same time. It's like a soft edge singularity that we're inside of. It's only when you're on the outside of a singularity, I think, that you really want to call it a singularity. Because these people can escape. We, in time, could move outside. But when you're seeing it from the inside, you think you won't be able to come out. But this is very simple. The hydrogen slowly coalesces, becomes stars, becomes galaxies, becomes a black hole at the moment of inversion of neutrons and other things that fall in later. Okay. Becomes the vacuum energy for a brief moment. Because space is one continuous thing, the loss of that neutron here needs to be accounted for. Where's that neutron? Well, that neutron is now here. It's that simple. It's conservation. By following that simple rule, it makes perfect sense. Gravity slowly repackages that blown up neutron back into a neutron, and then it blows up again. Back into a neutron, blows up again. This is like a thermodynamic cycle. Gravity's contributing the energy. Where does gravity get the energy? It's because gravity isn't really an energy. It has to do with the density of space and the isotropic, like, lack of viscosity, I think, is really the best way of looking at it. But there, down to 8 minutes.